7.5 billion years. That's how old scientists estimate Three-Eye Atlas is. 7.5 billion years traveling through the darkness between stars. 7.5 billion years since it left whatever system gave it birth. To put that in perspective, our solar system, our Earth, our entire evolutionary history from single-celled organisms to humans reading these words, all of that happened in 4.6 billion years. Three-Eye Atlas is older than our entire world. It's older than the rocks beneath your feet. It's older than the moon that lights our nights. This object has been traveling through space since before Earth existed. Think about what that means. When Three-Eye Atlas began its journey, our sun was just forming in a collapsing molecular cloud. The planets didn't exist yet. There was no Earth, no Mars, no Jupiter. Just a young star surrounded by swirling gas and dust. And somewhere else in the galaxy, 7.5 billion years ago, something happened that sent this object on its endless voyage. Was it a natural ejection, gravitational interactions during planetary system formation flinging comets into the void? Or was it something else? Was it launched deliberately, sent with purpose, carrying cargo or information, or just the ambition of beings who wanted to touch the stars? We don't know. We can't know. But we can think about what Three-Eye Atlas might have witnessed during 7.5 billion years of travel, what it might have passed, what civilizations might have risen and fallen while this object drifted silently through the galaxy. Because if life arose on Earth, if intelligence evolved here in just 4.6 billion years, then in a galaxy 13.6 billion years old, with hundreds of billions of stars and trillions of planets, life must have arisen elsewhere. Intelligence must have evolved, civilizations must have reached for space, and some of them, maybe many of them, must have failed, must have destroyed themselves or been destroyed by circumstances beyond their control, must have left ruins, relics, and ghost worlds that Three-Eye Atlas might have passed in the eternal night. The Fermi paradox asks the fundamental question: if the universe is so vast, if the conditions for life seem so common, if technological civilizations should be everywhere, then where is everybody? Why don't we see evidence of alien intelligence? Why haven't they visited us, contacted us, left unmistakable signs of their existence? The paradox has many proposed solutions. Maybe civilizations are rare. Maybe they destroy themselves quickly. Maybe they're there but hiding. Maybe they've transcended physical existence. Maybe interstellar travel is impossible. Maybe we're looking in the wrong ways for the wrong things. Each solution has advocates and critics. None fully resolves the paradox. But consider another possibility, one that researchers at NASA's Jet Propulsion Laboratory and institutions worldwide have started discussing more openly in recent years. Maybe the galaxy is full of dead civilizations. Maybe intelligence arises commonly, but survives rarely. Maybe the galaxy's history is written not in successful spacefaring empires, but in failed attempts, extinct species, and worlds where something went catastrophically wrong. Maybe Three-Eye Atlas, traveling for 7.5 billion years, has passed dozens or hundreds or thousands of star systems where life once flourished and intelligence once contemplated the cosmos. Systems where civilizations arose, built cities, developed technology, reached for the stars, and then, for reasons we can only speculate about, vanished. The timeline supports this grim hypothesis. Statistical models published in 2020 suggest the Milky Way reached peak civilizational development approximately 5 billion years ago. Based on the prevalence of sun-like stars, the frequency of potentially habitable planets, the time required for complex life to evolve, and probability distributions for technological development, researchers calculated that if intelligent civilizations arise at all in our galaxy, most of them would have emerged between 8 and 5 billion years ago. Most would be ancient, most would be far older than humanity, and most, statistically, should still exist unless something prevents long-term survival. We don't see them, we don't detect their radio signals, their megastructures, their modified planets, their interstellar spacecraft. The galaxy is quiet. The cosmic background is silent except for natural electromagnetic phenomena. If thousands or millions of civilizations arose 5 to 8 billion years ago, where did they go? Why don't we hear them? The most parsimonious answer is that they're gone. Not hiding, not transcended, not undetectable, just gone, dead, extinct. leaving behind only whatever artifacts might survive billions of years in the harsh environment of space. 3I Atlas comes from the thick disk region of the galaxy. That's a structural component containing older stars, metal-poor stars, stars that formed when the Milky Way was younger and had been through fewer stellar life cycles. The thick disk stars are typically 7 to 14 billion years old. If 3I Atlas formed in a system in that region, if it was ejected or launched 7.5 billion years ago, then it comes from a time when our galaxy was younger, more active, potentially teeming with civilizations that arose around ancient stars. What did that galaxy look like? What was happening 7.5 billion years ago in the volume of space 3I Atlas has traversed? We can make educated guesses. The galaxy was smaller then, more compact. The spiral arms had different configurations. Star formation rates were higher. Supernovae were more frequent. The galactic center was more active. Conditions were in some ways more hostile to long-term stability. But conditions were also ripe for planetary system formation around metal-enriched stars. The first few generations of stars, the ones that formed in the galaxy's first few billion years, had almost no heavy elements. They were pure hydrogen and helium. You can't build rocky planets or complex chemistry without carbon, oxygen, silicon, iron, the elements forged in stellar cores and dispersed by supernovae. But by 7.5 billion years ago, enough stellar generations had lived and died that heavy elements were abundant. Planets could form, life could arise. And if life arose, if intelligence developed, those civilizations would have faced challenges we can barely imagine. They would have been alone in ways we're not. No prior examples to learn from, no ruins to study, no evidence that space travel was possible, or intelligence was common, or the universe was anything other than vast, empty, and indifferent. They would have been first, pioneers, experimental subjects in the universe's laboratory. And pioneers often fail. First attempts often end badly. The history of life on Earth is written in extinction events, failed evolutionary experiments, species that seemed promising but couldn't adapt when conditions changed. Why should the history of intelligence in the galaxy be any different? The Great Filter is a concept proposed to explain the Fermi paradox. It suggests there's some barrier, some challenge, some test that prevents most life from reaching advanced technological civilization and spreading across the galaxy. The question is where the filter lies. Is it behind us, making the emergence of intelligence incredibly rare so that most planets never develop life at all? Or is it ahead of us, meaning intelligence arises commonly, but something prevents civilizations from achieving long-term stability, expansion, and survival? The silence of the galaxy suggests the filter is ahead. The fact that we exist, that intelligence arose here on what appears to be an unremarkable planet around an unremarkable star, suggests that getting to our level isn't impossibly rare, which means the challenge comes next, which means most civilizations don't survive long after they develop technology capable of detecting their own mortality. Nuclear weapons, climate change, artificial intelligence, biological warfare, nanotechnology, asteroid impacts, supervolcano eruptions, nearby supernova explosions, gamma-ray bursts, solar flares. Any of these could end civilization on Earth. Some are self-inflicted threats, dangers we created through our own technological development. Others are external cosmic hazards that planets face regardless of whether intelligent life evolves on them. The question isn't whether threats exist. The question is whether civilizations typically develop the wisdom and coordination necessary to survive them. Human history suggests cause for concern. We've come frighteningly close to nuclear war multiple times. Climate change proceeds despite clear evidence and warnings. Existential risks multiply as technology advances. We're not safe. We might not be survivable. And if we're typical, if our challenges are the challenges all emerging civilizations face, then the galaxy might be full of worlds that didn't make it. 3I Atlas might have passed some of those worlds. Statistical models of galactic stellar motion suggest that over 7.5 billion years, at its estimated velocity of approximately 200,000 kilometers per hour, 3I Atlas has traveled roughly 10,000 light-years through the galaxy. That's a significant volume of space. That's thousands of star systems. If even 1% of star systems develop planets, and even 1% of those planets develop life, and even 1% of those develop intelligence, 3I Atlas should have passed dozens of systems where civilizations arose. Maybe more if life is common. Maybe hundreds. And if most of those civilizations failed to survive their first few thousand years of technological development, 3I Atlas might have witnessed the aftermath. What would that look like? What signatures do dead civilizations leave? On Earth, if humanity vanished tomorrow, within a few thousand years, most evidence of our existence would erode away. Buildings would crumble, roads would fracture, metal would corrode, plastics would degrade. Within 100,000 years, geological processes would bury or disperse almost everything we built. Within 1,000,000 years, only the most durable artifacts would remain. Some stone structures, radioactive waste repositories if they survive, modified geology from mining and drilling. Within 10 million years, even those would be gone. Earth would look wild again, as if intelligence had never walked here. The only lasting evidence might be changes to atmospheric composition detectable through spectroscopic analysis or artificial satellites that remain in stable orbits for millions of years before eventually decaying and burning up. But space is different. In the vacuum between stars, artifacts can survive indefinitely if they're built from durable materials. Cosmic ray bombardment damages surfaces, turns ice into radiation-processed crusts, sputters away volatile materials over billions of years. But metal structures, ceramic composites, crystalline information storage media, these could persist. A spacecraft built to last, sent on an interstellar mission, could travel for billions of years and still be recognizably artificial when it arrives somewhere else. 3I Atlas, if it's artificial, proves this. Its surface has been transformed by 7.5 billion years of radiation, but underneath that radiation crust, if there's technology, it might still function, or at least remain detectable as something that nature doesn't produce. What about planets? Could 3I Atlas have passed worlds where civilizations once thrived and failed? What would those worlds look like from a distance? Probably barren, probably lifeless. Atmospheres that once held oxygen or showed biosignatures would have changed composition over millions of years without life to maintain them. Structures on the surface would have eroded. Cities would have become rubble. Rubble would have become dust. Dust would have been buried or dispersed by wind and water and geological activity. From space, using the kind of sensors an interstellar probe might carry, you probably couldn't detect that intelligence had ever existed there. You'd see a planet, maybe in the habitable zone, maybe with water and an atmosphere, but nothing screaming civilization, nothing obvious. The galaxy doesn't preserve failure, it erases it. Unless 3I Atlas was designed to remember, unless it's not a comet at all, but a probe. A self-replicating explorer sent to map the galaxy, to catalog what's out there, to record what happens to planets and civilizations over billions of years. If it's artificial, if it was built 7.5 billion years ago by some ancient intelligence, then it might carry records of everything it encountered during its journey. Star systems visited, planets observed, biosignatures detected, technosignatures noted, and civilizations that no longer exist, documented in whatever format its creators used for data storage. The concept of self-replicating probes, often called von Neumann probes, after mathematician John von Neumann, who formalized the theory, represents one proposed solution to the challenge of exploring an entire galaxy. You can't send single probes to every star system. That would require launching billions of spacecraft, which is economically and logistically impossible for any civilization. But if you send out probes capable of self-replication, the math changes completely. Launch 10 probes. They reach 10 star systems. Each builds a copy of itself using local materials, asteroids or comets or debris around those stars. Now you have 20 probes. Those reach 20 new systems. Replicate. Now you have 40. The growth is exponential. Within a relatively short time, cosmologically speaking, perhaps 10 to 50 million years depending on travel speed and replication time, the entire galaxy is explored. Multiple studies have modeled this process. Research published in 2022 by astronomers at the University of Edinburgh calculated that a single self-replicating probe, traveling at just 0.1% the speed of light and spending 1,000 years at each star system to replicate, could explore the entire Milky Way in approximately 100 million years. That's fast. That's a blink on cosmic timescales. If any civilization launched self-replicating probes during the first 90% of galactic history, those probes should have reached every star by now, including ours, including the solar system, including Earth. So where are they? That's the core of the Fermi paradox as applied to probes rather than civilizations themselves. If exploring the galaxy is this straightforward, if it doesn't even require faster-than-light travel or exotic physics, just patient spacecraft that reproduce themselves, then why don't we see evidence of these probes everywhere? Why hasn't one landed on Earth and introduced itself? Why don't we detect their communications, their activities, their presence in our own stellar neighborhood? Maybe we do. Maybe 3i Atlas is exactly that evidence. Maybe it's been in our solar system far longer than we realize, dormant and drifting, indistinguishable from the billions of comets in the Oort cloud, waiting for something to trigger activation, waiting for radio signals, waiting for evidence of technology, waiting for a star system where intelligence has emerged and reached the point where it can be observed and documented. And now, after millions or billions of years of patient waiting, it's activated, it's maneuvering, it's approaching for a closer look, not to communicate necessarily, not to make contact, just to record, to document, to add one more entry to the catalog of civilizations it's encountered during 7.5 billion years. If that's what's happening, if 3i Atlas is a von Neumann probe, then it carries data, 7.5 billion years of observations, thousands of star systems visited or surveyed, dozens or hundreds or thousands of planets where biosignatures were detected, and some number, impossible to guess, of civilizations encountered, civilizations that were thriving when 3i Atlas passed, civilizations in their early development, pre-technological, observable only through atmospheric chemistry or seasonal changes suggesting agriculture, civilizations at our level, broadcasting radio signals, launching satellites, just beginning to understand their own fragility, and civilizations more advanced, building structures visible from interstellar distances, conducting operations on scales we can barely imagine. Some of those civilizations might still exist, might have survived whatever challenges emerging intelligences face, might be out there right now, millions or billions of years old, stable and enduring. But statistical arguments suggest most didn't survive. Most faced the Great Filter and failed. Most destroyed themselves or were destroyed before achieving long-term stability. And 3i Atlas, if it recorded their existence, now carries the only remaining evidence they ever lived. Think about what that means. Think about the archaeological value of an artifact that's visited thousands of star systems over 7.5 billion years. Every major civilization that arose and fell in that volume of space during that span of time, potentially recorded, their radio signals captured and stored, their atmospheric compositions analyzed, their developmental trajectories documented from pre-industrial to whatever final state they reached. If we could access that data, if 3i Atlas carries it, and if we could retrieve it, we would have answers to questions humanity has asked since we first looked at stars and wondered if anyone else was out there. We would know how common intelligence is. We would know whether most civilizations survive or fail. We would know what kills them, whether it's nuclear war or climate collapse or artificial intelligence or something else we haven't even considered. We would know if spreading to multiple star systems helps, if civilizations that colonize other worlds survive longer than those that remain on single planets. We would know if there are patterns, commonalities, warnings we should heed, or strategies we should adopt. 3i Atlas might carry the collected wisdom and tragedy of galactic history, and it's approaching Earth right now. But accessing that data, if it exists, requires several things. First, we need to confirm 3i Atlas is artificial. That means detailed observations during December's closest approach, images showing structures incompatible with natural formation, spectroscopic data revealing materials nature doesn't produce, radio signals or other emissions suggesting active systems, something unambiguous enough that the scientific community reaches consensus. That hasn't happened yet. The debate continues. Uncertainty remains. December 19th might resolve that uncertainty or deepen it. Second, we need to get close. Remote observation from 270 million kilometers away has limits. Even the best telescopes can't resolve features smaller than a few hundred meters at that distance, to see fine structure, to detect subtle signs of technology, to distinguish between surface erosion from cosmic rays and deliberately designed configurations. We need proximity. We need a spacecraft to intercept 3I Atlas, match its velocity, fly alongside it, gather data from mere kilometers or meters away. That mission doesn't exist yet, but concepts have been proposed. Launch windows exist. If political will and funding materialize, we could have a probe en route within a decade. Third, assuming we confirm artificial origin and successfully intercept, we need to figure out how to communicate with or extract data from an object built by beings who died billions of years ago. That's not trivial. Human data storage formats become obsolete within decades. Computers from the 1980s can't easily read modern file systems. Technology evolves. Standards change. Now imagine trying to access data stored by an intelligence that evolved independently, thinks differently, uses completely alien technological frameworks, and has been dead for longer than Earth has existed. The challenges are staggering, but maybe not insurmountable. Any intelligence that builds interstellar probes designed to function for billions of years must solve the same problem. How do you store data in formats that remain accessible over astronomical timescales? How do you build interfaces that can communicate with species you've never met and can't predict? The answer might be universal principles. Mathematics is universal, physics is universal. Certain sequences, prime numbers, fundamental constants appear the same to any intelligence that understands reality. A data archive intended for unknown future intelligences would likely use these universal principles as keys, as Rosetta Stones, as ways to bootstrap communication and understanding. Researchers in the SETI community have thought about this extensively. The Pioneer plaques and Voyager golden records, sent on spacecraft leaving the solar system in the 1970s, used exactly these principles. Images based on binary mathematics, pulsar maps for navigation, physical constants to establish units. The assumption was that any intelligence capable of intercepting those spacecraft would recognize the patterns and deduce meanings. We applied the same logic when designing messages transmitted toward nearby stars via radio telescopes. And presumably, any intelligence advanced enough to build self-replicating probes billions of years ago would apply similar logic when designing systems meant to communicate with species they would never meet. So maybe it's possible. Maybe if 3I Atlas is artificial, if we intercept it, if we find data storage systems, we might actually succeed in retrieving information. And if we do, if we unlock records spanning billions of years and thousands of star systems, we would need to confront what those records contain. The evidence of civilizations that failed, the documentation of worlds where intelligence arose, flourished briefly, and vanished. The gallery of ghosts that 3I Atlas passed during its eternal journey. What would we learn from that gallery? What patterns would emerge? Would we see that most civilizations destroy themselves through warfare, confirming that nuclear weapons and human aggression are universal threats? Would we see that climate change kills most planetary societies that industrialize without understanding ecological limits? Would we see that artificial intelligence, once it surpasses biological intelligence, tends to eliminate its creators? Would we see that cosmic hazards, asteroid impacts or supernova or gamma-ray bursts kill indiscriminately regardless of how careful civilizations are? Or would we see diversity, different failure modes for different species, no single dominant pattern, just the universal truth that survival is hard and most don't make it? We might see something unexpected. Maybe civilizations don't fail catastrophically. Maybe they transcend. Maybe advanced societies reach a point where physical existence becomes optional, where they upload themselves into pure information, where they abandon planets and matter entirely for something we can't even conceptualize. To a probe passing through, that would look like extinction. The planets would go silent, the radio signals would stop, the cities would crumble. But it wouldn't be death, it would be transformation. 3I Atlas might carry records of species that succeeded so thoroughly they no longer need physical form, no longer interact with the material universe, no longer leave traces that probes can detect. Not dead civilizations, but ascended ones. Not failures, but graduates. Or maybe civilizations don't spread because they choose not to. Maybe the universe is full of intelligent species that develop technology, reach the capability for interstellar travel, look at the costs and challenges and timescales involved, and decide it's not worth it. Decide that staying home, building sustainable, stable societies on their homeworlds, achieving equilibrium with their environments and each other is more valuable than expanding across the stars. To a probe, that also looks like stagnation. Radio signals might continue, but they don't get stronger, don't spread to other star systems, don't show the signatures of growing galactic civilizations. Just quiet contentment, just species that reached enough and stopped. 3I Atlas might have passed hundreds of these, civilizations still there, still thriving, just not interested in the kind of expansion that makes them visible across interstellar distances. But that's speculation about civilizations. 3I Atlas might have passed. Let's talk about what happens if it passed our solar system before, because there's a possibility nobody discusses much, but that explains several anomalies. What if 3I Atlas isn't visiting for the first time? What if it's been here before, millions or billions of years ago, during one of its previous orbits through this region of the galaxy? What if it observed Earth when life was young, when dinosaurs ruled, when our ancestors were still swimming in oceans? What if it recorded all of that and is now returning to check on progress? The orbital dynamics make this possible. 3I Atlas is traveling on a hyperbolic trajectory, which means it's not bound to the sun, it's just passing through. But hyperbolic doesn't mean straight line. The object curves around the sun, gravity bending its path, then heads back out into interstellar space on a different trajectory than it arrived. Over millions of years, as it travels through the galaxy, its path intersects different regions. Galactic rotation, gravitational interactions with massive objects like molecular clouds or star clusters, these gradually alter trajectories. It's entirely possible for an object on an interstellar orbit to pass through the same general region of the galaxy multiple times over billions of years. If 3I Atlas last visited the solar system 500 million years ago, Earth would have looked completely different. The continents were still forming into configurations we wouldn't recognize. Life existed, but complex life was just emerging. The Cambrian explosion, the rapid diversification of multicellular organisms, had recently occurred. Primitive fish swam in ancient oceans. Plants hadn't colonized land yet. Nothing resembling modern ecosystems existed. If 3I Atlas observed Earth then, documented the chemistry, detected biosignatures in the atmosphere, it would have recorded a world of potential, a world where complex life was just beginning, a world that might, given enough time, develop intelligence. Now it's back. 500 million years later, a blink on the timescale of its journey. And what does it see? A planet transformed, continents rearranged, ecosystems covering every available surface, and intelligence. Radio signals, satellites, cities glowing with artificial light visible from space. The transformation from that ancient Cambrian world to modern Earth represents one of the most dramatic evolutionary developments possible, from primitive multicellular life to technological civilization in 500 million years. That's fast. That's interesting. That's worth documenting. That's worth approaching for a closer look to confirm the sensors are correct, to verify that this world really did make the jump from simple life to spacefaring intelligence. Or maybe it last visited 50 million years ago. Earth was recovering from the asteroid impact that killed the dinosaurs. Mammals were diversifying, filling ecological niches left empty by the extinction. Primates were emerging, small and unremarkable, just another mammalian lineage with no obvious destiny. If 3I Atlas documented Earth, then nothing would have suggested intelligence was imminent. Just another planet with successful biosphere recovering from catastrophe, continuing its evolutionary processes, likely to remain biologically rich but technologically silent for tens of millions more years at least. But something changed. 50 million years later, primates evolved bigger brains. Tool use emerged, language developed, agriculture transformed societies, civilization arose, technology exploded. The transformation from those early primates to modern humans happened in an evolutionary instant. And now, 3i Atlas returns to find a world that went from biological normalcy to technological emergence in the shortest possible time. That's remarkable. That's unprecedented if 3i Atlas has visited thousands of worlds and seen how evolution typically proceeds. That's worth investigating, worth documenting, worth understanding what happened here that allowed intelligence to arise so quickly and develop so rapidly. These scenarios assume 3i Atlas is artificial and has mission parameters that include periodic revisits to interesting star systems. That's speculative. No evidence directly supports it, but it would explain why the object seems to be approaching Earth specifically rather than just passing through the solar system on an arbitrary trajectory. It would explain why the timing of closest approach allows optimal observation from Earth-based telescopes. It would explain why governments are preparing as if something significant might happen in December. Because if 3i Atlas visited before, if it documented Earth's biological history, if it's returning now to assess whether we've achieved technological civilization, then its mission parameters might include attempting contact or revealing its nature to species that reach a certain developmental threshold. That's a huge if. That's science fiction thinking. But science fiction thinking is sometimes correct. Concepts like artificial satellites, space stations, interplanetary travel, all were science fiction before they were reality. The idea of interstellar probes visiting Earth isn't physically impossible. It's just unprecedented in human experience. And unprecedented doesn't mean impossible. It means we have no framework for understanding what's happening. We're making it up as we go. We're trying to interpret observations using scientific principles while acknowledging that if those observations represent artificial technology billions of years more advanced than ours, our interpretations might be completely wrong. The December approach brings clarity, whatever that clarity reveals. If 3i Atlas continues behaving like an unusual but natural comet, if it fades predictably as it recedes from the sun, if no unexpected activities occur, then the artificial hypothesis loses support. Then we're back to conventional astronomy, studying an interesting interstellar comet with anomalous properties that challenge our models but don't overturn our understanding of what's possible. That's the most likely outcome. That's what most scientists expect. But if something else happens, if December 19th brings observations that can't be explained naturally, if the object does something that demonstrates intelligent control or purpose or technology, then everything changes. Then we're confronting the reality that we share the galaxy with other intelligences, that probes have been mapping stellar systems for billions of years, that Earth has been observed, documented, studied by artifacts created by beings we can never meet because they died before our world existed, that we're not discovering the galaxy for the first time, we're being rediscovered, we're being revisited, we're being checked on by systems that have watched us develop and are now confirming we've reached a threshold worth noting. What happens after that confirmation is anyone's guess. Maybe nothing. Maybe 3i Atlas records our existence and continues its mission, visiting other star systems, adding us to whatever database it maintains, and we never see it again. Maybe it attempts communication, transmits information we can detect and eventually decode, shares whatever knowledge its creators intended for species that achieve our level of development. Maybe it releases smaller probes that remain in the solar system, establishing permanent monitoring stations, ensuring that future observations can track our progress or our failure. Maybe it does things we can't predict because its programming reflects intelligence and motivations completely alien to our experience. Or maybe we're overthinking. Maybe 3i Atlas is just a comet, just ice and rock from another star system, following trajectories determined by gravity and chance, exhibiting unusual but natural properties because interstellar objects have characteristics we haven't fully understood yet. Maybe the anomalies that seem so significant are just gaps in our knowledge, not evidence of artificial origin. Maybe Occam's razor applies. The simplest explanation that fits the facts is usually correct, and the simplest explanation is natural comet, not ancient probe. Maybe we're seeing patterns that aren't there, imposing meaning on randomness, desperate to find evidence of other intelligences because the alternative, that we're alone in the universe, seems too terrible to accept. December 19th tells us which maybe is correct. December 19th is when the object approaches close enough for detailed observation, when amateur astronomers worldwide point their telescopes upward and document whatever happens, when professional observatories coordinate their efforts to capture every possible wavelength, every spectrum, every image, when governments watch through classified monitoring systems and prepare communication strategies for whatever revelation might come, when humanity collectively holds its breath and waits to see if this visitor from beyond carries answers to our oldest questions or just adds more mysteries to contemplate. 7.5 billion years of journey, thousands of star systems potentially visited, hundreds of planets where life might have emerged, dozens of civilizations that might have risen and fallen during its voyage. All of that history, all of that experience, all of that data potentially encoded in an object currently racing toward us at 200,000 kilometers per hour. An object that will pass Earth on December 19th, 2025. An object that might be the most significant discovery in human history, or might be an interesting comet we'll study and forget. We don't know yet. We can't know yet. We can only watch and wait and prepare for whatever truth arrives. The truth about 3I Atlas. The truth about what it saw during 7.5 billion years traveling through a galaxy that might be full of life, or might be a graveyard of failed civilizations. The truth about whether we're being visited by remnants of ancient intelligence or just observing natural phenomena we don't fully understand. The truth about humanity's place in a universe that seems vast and empty and silent despite all our searching for evidence that we're not alone. December 19th brings answers, whether we're ready for them or not, whether they confirm our hopes or our fears or reveal something entirely unexpected. The object approaches, the date approaches, and soon, very soon, we'll know.